So in this video, we are going to be discussing how to time and set the points on a standard 12-volt ignition. We're going to be using a variety of tools, one of them being contact cleaner. See if I can get that in the camera. Contact cleaner. We will be cleaning the points using what's called a flex stone and a burnishing stone for cleaning points, feeler gauges, and 3 different types of meters: a digital meter, in this case a Fluke, an analog meter, an old-time Suzuki analog meter, and a point checker, the most unobtainium thing in the world, but they work really good on points and for magnetos. Too bad they don't make these anymore. I probably bought this pretty close to 50 years ago. And I've kept it in good shape. It's been an excellent device. And last but not least, a plain old trouble light. Nothing more than you hook it up one side to ground and you just poke around and you see if you can get 12 volts. And again, this is just another old snap-on one. Anyway, we're going to go through and I will show you how to set the points, how to clean the points, how to set the points, how to set the timing, how to get everything aligned so that when you go to start your motorcycle for the first time or any time, the points are at least set where they need to be and the timing is set properly. It's important. Instead of kicking on a thing 500 times, make it so you don't have to kick on it once or twice. So in all of this, getting your timing right and getting everything to work right is really important. So the first thing we're going to need to do before we start anything is remove the cover from our points. So we'll get this guy out of here. Go around the camera here. Okay, now that we have the cover off, we now expose the points and the condenser. And how this works is, what we're going to do here is we are going to adjust the points to their proper clearance. Then we are going to set the timing. And before we do that, maybe the best thing to do is explain how the points interact with the coil and how everything works. So let's just take a brief look at how that does that. Let me move the camera over here and to our little whiteboard. And we'll start with the points. Okay, so we have a set of points and we're going to draw those. This is ground. And we're going to draw these points just so they're a little bit easier to understand. And there's our points, and then it will go this way. So these open and close. And what we have here is also our condenser. Okay, so our points open and close here. And this goes straight up to a coil. And the way that works is there is a winding inside the coil, and that winding goes directly to your key switch. And the key switch goes directly to the battery, which in turn goes to ground. So this is the circuit that allows our coil to work. And then there's a secondary winding inside the coil that is, one side is hooked to here because it's where it gets its ground source, and this side goes over to our spark plug. And we'll just draw the spark plug kind of crappy, but, and it goes, there's the electrode that goes through there, and then this guy, which is grounded, and there's our little gap that we have, and this guy goes off to ground. So now, this is basically the complete circuit. The points open and close. We'll just make this, we'll put a little hinge right here. The points open and close, and so when these points close, we'll draw that in. When they're closed and they're connected, we now have ground going through here, through our coil, and then when we close this switch, which is hooked to the battery, now we have power going through here, and this coil can energize. We have ground and 12 volts. We'll put that in. And once that happens, this coil energizes. Now what happens is the points break. And once those points break, they open up, the field that was in here collapses. There was a magnetic field in here that we built up, and that collapses. And as soon as that collapses, it causes this coil to energize, because that's the way, it's kind of like a transformer, and we won't go into that. But it's a transformer, and it discharges through, it has to go somewhere, and it goes through the spark plug, and we get a little spark right here. And we get a spark. And that's all there is to it. Now, the thing that we need to do is understand that the points have a certain setting, and what that setting does is how much time the coil has to charge. And if the points aren't set right, the coil won't saturate properly, or it won't desaturate properly. So you need to make sure that the points are within spec, and once you do that, then you get the timing right, and then the engine can work right. So this is a basic explanation of how a coil works and how your ignition system works. And this is just a 12 volt, excuse me, get that down, 12 volt, just standard ignition. That's all that this is. This is not your magneto ignition that you will find in some of the other little bikes that don't require a battery. We'll go into those, we'll find a bike and we'll do a good explanation on that. But this is your basic piece here of how a coil works. Coil with your points. There's nothing fancy going on in here. This is your condenser, and the condenser does this. What happens is when the points break, you have a field going here, and it has no place to go. And what it wants to do, it wants to arc across the points. And anytime you've ever dealt with a coil or 12 volts, you see it arcing. And the bad part about that is when it starts to arc, anything that starts to arc is going to try and weld itself together. You've seen it. You've touched something and it almost wants to weld itself. And that's where the points get all messed up. You see all that burning in there. That's because they're arcing in here and they're trying to weld themselves together. Well, the condenser, what it does, as soon as the points break, this tries to discharge because it has no other place to go. And it goes into the condenser. And the condenser, think of it like a sponge. It just soaks up electricity. And it goes in and soaks it up. And not only does that cause this to discharge quicker and give you a better spark, but it also drains some of the energy away from this point. So it will go on ahead through here, charge up, and help those points live, help the spark, do everything else. When the points close, we'll redraw it, and when the points close, when they come together, this guy drains off completely through ground. So he is ready to go. As soon as those points break, he's ready to accept that charge. So it all works in harmony. It's a very simple system that was invented way back when, but it still works in there. Now CDI and all those other things are a different thing. We'll be dealing with those and how the transistorized ignitions work. That's a whole other discussion. But for this instance, in this particular type of motorcycle, this is the system you have. 12-volt ignition, you turn on the key, you get power, that's what it is. So that's how it works. Now we'll go ahead and see some practical ways to go on ahead and be able to set the timing, and I'll show you a couple different ways to check it, with or without a battery, maybe with a trouble light, maybe with a meter. There's a few different ways we can do this. So what we're going to do is we'll go back and we're going to go aim at the points and see if we can see the timing marks in there and show you how to adjust the points and address all the issues you might have in there. We'll talk a little bit about point wear and so on and so forth. So that's next. Okay, so the first thing we need to talk about is cleaning the points. I've seen a lot of people do different things to clean points, but what we have to remember about points is there's a coating on those points that they put on, and it's a little harder than just some soldery material. So that it's to allow it to wear and allow to arc without it destroying the points. So anyway, you don't want to be too aggressive with the points as far as what you use to finish them. I use something called a flex stone, and this is designed, it's a very fine stone, and it's flexible, and it's made for cleaning points. That's what it's there for. So what I do usually is I put this in, and I use some contact cleaner as a lubricant and as a cleaner, and then I just work it back and forth until the points feel pretty good. And it doesn't take much. Then you open up the points, clean them. Then what I do, I have something called a point burnishing tool. And this point burnishing tool is a very, very fine, it's got a very, very fine grit on it. It's got a very fine surface on it. And this polishes that surface a little bit so that you get really, really good contact. So again, I just work it in there, and it just cleans and burnishes those points to where they look pretty good inside. It'll polish them up a little bit. This is not something you have to do. This is just something I do to, guarantee that the points are going to work right. You don't want anything too thick either, because as the points open up, it kind of turns into a V, and you end up, if it's open too far, you're only going to be surfacing off these edges. So you want to keep them as close to being together as possible. And these types of flex stones and burnishing tools keep the points pretty much together. So now what you have is a nice cleaned off surface, and our points can now have their best opportunity to work. The next thing we want to do is we want to set the point gap. And this book calls for 0.3 to 0.4 millimeters. And I like to use a small feeler gauge for this. And these are designed for points, and they're very, very, it makes it easier to handle. It's got a bigger set. These are snap-ons, but it's got bigger feeler gauges in it, but these small ones work great for dealing with points. So in this particular case, somewhere between 0.3 and 0.4, 15 thousandths works out just about right. It's 3.81 something, and that works out well for doing this. So what we need to do first is rotate the engine so that the points are to their most open position. Now this particular engine, this is a KZ400, and it rotates backwards. You can see there's, well, I don't know if the camera can pick it up, but there's an arrow here telling you which way the engine turns. And the reason it does that is in most bikes, it's a direct gear, and so that you need this part to turn backwards, and then a normal engine will turn this way, and then the clutch will turn counterclockwise, and then that turns the shaft, which will turn the other direction. This one's got a chain in it, so the engine on this one turns backwards. So the first thing we do is we just go on ahead and we just turn this around until the points are at their most open position. And right there, they've opened up about as far as they're going to open. I can see it on the cam. The cam is the biggest part of the cam right there. So what we want to do is we want to take our feeler gauge and we want to just get it so it goes in and there's almost zero resistance. And right now, there's a little bit too much. It's just moving the points a little bit. So what we're going to do is we're going to loosen up the screw that holds the points. Loosen that up. And if you look, there's little pry points inside here, which makes it easy for you to stick a screwdriver in there. And you can take and pry the points open ever so slightly in this case. And I just moved them imperceptible amount. Tighten the points back down and try it again. And that almost did it. There's just a little teeny, maybe just a tiny bit more. And you keep on working it. You be patient. Pry them open a little bit. And tighten it back down. When you tighten the screw, it changes things. And that's going to be the issues. Now this is a little loose. Okay, I went a little too far. I can feel that it's just a little bit too loose. So back in here, and we'll just take these and we'll close them up ever so slightly using the pry points that provided. Tighten it back up. Still too loose. And you have to go back and forth a few times with it. Just, you know, it's better to be patient and work it till it's right. And we are almost there. Just maybe just a little bit. Let me loosen this up one more time and just pry it open just a shade. And the best thing to do is leave the screw a little snug. Don't loosen up the screw all the way, because then it changes it too much. One more time. Yeah, and you can see it can be a tedious process, but it's worth it to just be careful. There we go. That's just about perfect. It's just the tiniest amount of drag on that. It's just barely touching, but it's touching. Okay, so now the next thing we want to do, and this is really hard to show on camera, but inside here is there's a little mark, and that mark has got an F on it, and that means fire. That's when the thing fires. And so what we want to do is we're going to wind back our engine till the points close and just go in, and I don't know, I can't show you on camera, but there's an F mark in there, and what I'll do is I'll inject a picture of what this looks like. But right now it's sitting on the F mark. So the first thing we want to do is we want to know when the points break. And there's multiple ways to do this, and I'll show you several of them. Okay? So the first thing we want to do is, how about your standard old trouble light? It's a pointer, it's got a light bulb in it, and it will light up when you have power to it. So let me, I don't know if you can see that. I'll put it on a battery. I've got a battery in here that I'll roll this around where you can see it. So it just turns on when it gets power. I've got it on a battery. The battery charges on it, just for goodwill, but there we go. So that's what it is. So what we're going to do is we're going to connect our light here, and I'll put it here where we can see it. And we'll try anyway. I'll hook that to our point wire, which is right here. And I'm going to try and get this trouble light where you can see it. Oh yeah, that'll work. Can't do that. No, it won't work because it's grounded. I need it to where it's not grounded. Can we see it there? Yeah, we can see it. Good. So the next thing I need to do is I need to turn on our ignition switch. And the way I'll turn on our ignition switch is I'm going to do nothing more than hook the other side of our coil to the battery. So the light is on. So what's happened here is we're probably a bit too far advanced. So what we're going to do is we're going to rotate the, oh, nope, we aren't. We're almost perfect. Okay, I'm going to turn this. I've moved back off. I've turned the engine back a little bit, and the F mark, and again, you really can't see it, but it's right about here in the middle. Right in the middle is where it needs to be. There's a little mark inside, but it's right about back over in here. So I'm going to start turning this until the F mark lines up. And the F mark is going to line up right now. And our timing is perfect because the points are set correctly, but if you change these points, it will change the timing. So what we're going to do here is demonstrate how to set the timing if it was off. What we'll do is we'll make it go off, and then we'll go on ahead and then retime it. So I'm going to move this thing so that it's way too advanced. Get that. I've changed the timing now. Get this tightened down. Okay. And excuse me, I turned it that way. So what does that do? Well, let's see what it did here. Okay, so we're going to go, and I may have not moved it enough. I just didn't hardly move it. There's a problem. Let me move it some more. And it'll be way too advanced now, and this will allow me to show you how it works. Okay, so tighten those guys back up. We will go on ahead and put our test lead on here so we can see what's going on. If I can make that sit right. Let's see where we are. Okay, so here, so we are retarded. Excuse me, I went the other direction. We're retarded at the moment, so okay, so I've rotated the engine back, and here is full advanced, engine running advanced, and our F mark is not in the center, it's off a little bit. So what we need to do is retard the timing, which means we have to rotate this plate this way. And the reason we're rotating it this way because the engine turns into this, and the points have opened too early. So what we want to do is we want them to open later. So the cam is sitting here and we want to move it that direction, the same direction that the motor turns. So we'll loosen this up. And it kind of moved around a little bit. So now what we're going to do is we're going to take this guy, and there's some pry points on here. And this plate isn't the tightest in the world either. It kind of moves around. It's not really in there very good. So I'm going to move it back toward the center, tighten it back up, and see where we are. We've gone ahead and retarded the timing a bit. Make sure you tighten all three and make sure they're as tight as they're going to be, because what happens is if you do that and you tighten it, it'll change it a little bit. So what we're going to do here is keep on going, and our little F mark has lined up perfectly in there. Okay, so let's go through some of the various ways to check when your point's open. So we'll start with the fluke meter, or a digital voltmeter, and we have the ignition switch turned on at the moment. And what we'll do is we're going to use the DC voltage range. So on your meter you find DC voltage, and in this case it's a V with a little line and some dashed lines under it. That's DC voltage. And if we look, we're going to see that the points are closed at the moment. There's almost zero voltage in there. There's 0.033 volts. There's always going to read a little bit on there. That's just the impedance of the wires and whatnot going through. So what we want to do is we're going to rotate the engine until we see this change. Now, the one thing we have to be aware of is that on a digital voltmeter, the change is not instantaneous as you might think. The way that most meters work is they do a sample, and they just sample every few milliseconds. So the change is a little slow on the meter. So what you want to do is you want to go very, very slowly when you turn the crank. Also, when you turn the crank, you don't want to have your wrench here or here, because that has a tendency to move the crank to the side, and that will skew you a little bit. So you want your wrench to be basically on the same plane as your points. If the points are up here, you would then want your wrench to be down here or up here. So what we're going to do is we've rolled the crank back a little bit. We got 0.032 volts on it. The key is on. So we're reading voltage, and we're reading voltage through, coming through the coil and coming back down onto this, onto this connection. And this is connected onto where your points are. So we'll turn it until very, very slowly, and I'm going to just keep on trying to keep it in this plane. And we're starting to see some movement in here. That means the points are just starting to move a little bit. And as we go, we'll see a big change. And pow, right there. And if you heard it, the spark plug actually sparked. And if you look, when you inside here, that it is lined up perfectly on the F mark. So now, that's one way to do it. That's having voltage. So let's just say we don't have a battery or anything. We can do it a different way. We've disconnected our battery, and now we can use the ohms gauge to check. So all that we need to do is put on ohms, okay, and we've got 1.5 ohms, and that's just the resistance of the wires showing up. What we want is to see when the point's open. So what's going to happen is we're going to see this change from like a very low ohmage to infinity, or in this particular meter it just says OL for overload. So I'm turning it the direction it needs to go. very, very slowly so I don't change anything. And the meter has time to sample. And as we get close to it, it switched over to OL. Okay, that means the points have opened. And if we look, our timing mark is right on target. So that's one way. That's the way to use a digital voltmeter using volts or with the ohms. So let's try something else. And I'll go get another meter and we'll set that up. So now I've hooked up an analog meter, and this analog meter is when the needle is all the way over, that means the points are closed. That means there's a connection between the two terminals, and that shows that our points are closed. When this meter swings the other way, that's when the points will open. So we go ahead and we rotate the engine, and there it goes. We saw it swing the other way, and it's just sitting here. It's just kind of right on the cusp. I can move this around, and it will change. So that's exactly what the timing is, and our timing mark is again perfectly lined up. We'll go on to the next type. Oh, we can also use voltage on this. So let's do a voltage on this one. So what we can do is we can switch our meter to DC voltage, and we'll set it to 25 in this one. So then what we'll do is we'll take and turn on our key. Okay, the points are open at the moment, so we're reading our 14 some odd volts. So we'll back it up, go back. Now on this one, this is 0 volts, and that's 25. So we'll just roll it forward. This is with the key on. It just changed, and our timing mark is lined up perfectly. Again, that's just another way of dealing with voltage or ohms. The first one was ohms. The second one was voltage. We'll go on to the next one. Okay, and this we're going to use a point checker. And the point checker is with the key off only. It's just measuring the ohms on the points. Now, it's very, very sensitive. So we're close to this closed and open. It just reads a little bit high. But what's going to happen here, as soon as we roll the engine back, we will see it pop open. Or roll the engine forward, excuse me. And here you can see it just starting to go there, and there it goes. And if we look at our mark, it's right on target again. This is another way to deal with it. We'll go on to the next one. And last but not least, we have a power probe. This is the Maestro series. It's their super deluxe one, which I don't think is really worth it. The regular one's just fine. But what will happen here is you can't see the screen real well, but it does tell you what the voltage is. But there are lights on here. So what we're going to do here is we are sitting here, and it's making a bit of noise. We're sitting here with the points closed. Okay, and as soon as the points pop open, we'll see the power probe change. And there it goes. And again, our timing mark is lined up perfectly. So it's just telling us that happens. I'll roll it back. So that covers a few of the ways that you can check the timing. So hopefully this was helpful in helping you figure out how to time your motorcycle. There's other bikes out there with different types of point setups, but they all basically work the same way. The 4 cylinders got 2 sets of points, or some of them just have 1. It just all depends. So hopefully this helps. And that's how you time. That's how you set the points. That's how you set the timing using different methods to look at looking at it. You still get the same results. When the points open, they need to be at the little F mark. And once you do that, you are in good shape and you can move forward and move on to something else. It's a relatively simple operation. I just kind of drug it out so you can see all the different things that you have to do. So thanks for watching. We'll see you next time, and where we will be continuing on with working on the seat. It depends on what's coming. If the paint makes it here first or the foam makes it here first, whatever gets here first, that's what we're going to work on. So we'll see you next time. Don't forget to subscribe, and again, we'll see you next time.